Okay, today we'll be talking about how to create an SEO audit and analysis template that is meant to be a low-code solution like this, so you can reuse it any way you want, and we can, create various versions and improvements and so on. So this is the notebook, and this can be easily converted to an HTML file with simply those metadata tags over here. These are just options. We can, I think we should create we should have another session on reporting with Quarto. That's the name of the package. But this notebook can be converted to this HTML file. Okay, so there's no code here. You can present this to anyone without showing the code, and you have these navigation links and so on. Okay, so I'll go through this document, and every now and then I can switch back and forth to the code if you want, and if you have any questions, just let me know as we're talking. Okay, so this is based on public information only. Later on, we can incorporate stuff that's private, like Google Search Console or Google Analytics or any other private data that you might have. So I've crawled bit.ly.com, the website, and used its XML sitemap and robots files. So this is all only based on these files. Okay, so this is dynamically generated. The crawl date, it was the 14th of September. URLs crawled, it was this much. We can quickly check the URLs that are in the sitemap but not crawled, and vice versa. And we can immediately filter and find these and share them with our client or coworkers. Okay. Status codes. This is a chart specifically for status codes. Every group of status codes is in its own color rectangle, and you can go zoom in and see which, under 400, these are 403. 404, so 403 we had 56 URLs, which is 76% of the 400s, and so on. Next, we can look at the URL structure. So splitting the URLs into their components, we can see here that we have 8 directories, and we have a bunch of query parameters in many of the URLs. That's a lot of stuff over here. So a natural question is, how many values do I have in directory 2? Like this is empty. What percentage of my URLs contain a directory 2, directory 3, and so on, and query parameters? So this is answered here in this table. So the 100%, obviously these are, every URL contains them. In terms of directory structure, pretty much all URLs have directory 1 and 2. Almost half of the URLs have a third directory, and so on. So this gives you a perspective on how deep the directory structure is. In terms of queries, okay, there's a lot of them, but it seems that it's only in less than 2% of the URLs. And here we see what those query parameters are. The actual parameter is this part. So I just put query underscore just to distinguish between them and anything else that could happen can be in the on the URL. Okay, and next we can take each one of these columns and see what values we have. So in terms of scheme, everything's HTTPS 100%. Nothing much to see here. In terms of domain, that's interesting, because it seems we have a bunch of subdomains, and we can see how many pages we have for each of those subdomains. Okay, so we can, bit.ly.com, support, dev, accounts, and so on. Next, we can look at the query parameters. So 698 URLs do not contain query parameters, and the rest do. And these are the parameters that exist. They're just one each, and you can check what these are. Fragments, the majority of URLs do not have. 709 do not have a fragment, and the ones that do are these are the fragments that we have. And then we can move on to directory 1, and we can see that the blog is 66% of the pages. Pages is 19%. and so on. And we can do the same thing with directory 2 to see the percentages and how they're distributed in terms of content. Now there's another way to visualize these two directories, 1 and 2, with this tree map. So under pages, for example, we have 142 pages, which is almost 20% of the website. And we can zoom in and we see that we have resources, 97 pages, other, that's all lumped in here, landing pages. So that would be interesting. We know that they have 5 landing pages, and we can easily filter those and explore and see what those landing pages are, what they're focusing on, what they're promoting, and so on. Okay. So this is how the website is structured across the first and second directories. So, in the blog, they have 50 authors, for example, and so on. So next, we can take the crawl data frame and select the columns that we want and explore them one by one. So these are the columns that I have in the crawl data frame: title, body text, canonical, and so on. And we have 2 reports here. The first one tells me about the distribution of those text elements in the page. So the title tag, we have 616 pages that have 2 title tags on them, 88 pages that have 1 title tag, and so on. And these are the percentages, so you know what's going on. The meaning of these things differs from element to element. So having no H5 elements doesn't mean anything. It's just not an issue. But having a missing title tag might be an issue, and so on. So the interpretation here depends on what this element is. And the other report here is the word counts. It counts the words in every across the website for this element. So let's say we want the H1 tags over here. We can see that most pages have 1 H1 tag. We have 14 pages that don't have an H1 tag. We have 334 pages that contain 2 H1 tags, and so on. And these are the most frequently used words in the H1 tags. And we can make this like bigrams and trigrams. So when you do the bigrams, you can see that most H1s are how to. So that's interesting. It tells me a bit more about this website and what kind of content it has, or at least what they're focusing on. And we can see that there's 130 how-tos in their H1 tags. So, that tells me more about what they're doing. You can do the body text, for example. And these are the most used bigrams. So they focus on social media 4,149 times. Obviously, you have just 1 body text per page in all the pages. If you want to take unigrams, bit.ly is the most used word, links, marketing, and so on. So, the interpretation of this depends on how you understand the strategy of the website and, what you're trying to do. And it's up to you to interpret them. So you can do the same thing for any of the text elements in the crawl data frame. We can do the same thing with the numeric elements. Okay, so for example, let's take latency. The download latency is distributed like this. Mostly it's less than 1 second. And this is, we have 2 peaks over here. And if you want to have a higher resolution or lower resolution view of this histogram, you can just do like this. So let's say, give me 10 bins, okay? Or you want a higher resolution, so you can see the details of how the download latency is distributed, okay? So you can do the same thing with size, do it like this, and so on, okay? And you can do this again to any of the numeric elements, content length, response headers, and you can change it the way you want and filter so you can see what's going on. Okay. Another one is the canonicals. So what I'm doing here is I'm simply taking the canonical tag column and counting those tags, the URLs over there, and reporting them over here. So the first interesting thing here is that 116 pages don't have canonical pages, canonical tags. So that's the first finding over here. We can easily filter those and find them. And those pages have two canonicals pointing to them. So there are two URLs setting bit.ly.com as its canonical page, probably the page itself and some other page, pricing and so on. And as a summary, we can see how they're distributed in terms of what they link to. So 600 URLs point to themselves, which is 83%, and 6 URLs point to some other URL, and which is 1% of my data set. So this gives you a view, so you can immediately, filter, find out anything that you want about the canonicals and do whatever you want with them. So the next is redirects. This is a sample of like 4 or 5 redirects. Let me just take you through this one, number 89. So this one has 3 URLs. Okay, this one has been requested, and this is intermediate, and this is crawled. So the crawler went to this URL. It got a 302 redirect, sending it to this one, which is the intermediate page, and this one sent back a 302 status code, which sent me here, and this returned a 200 status code, and this was actually crawled. Okay, so you can see here the order. This was the first, the second, the third, first, second, third, first, second, and so on. And you can see the status of each one of these and in the intermediate pages. So you know what's going on. And this is over here is just metadata about the whole redirect. So this one has 1 redirect, this one has 2, and so on. And you see the download latency. Okay, so the distribution of the number of redirects, we can see it over here. 16 of my redirects had 2 redirects, so like 3 URLs in them, and 7 of my redirects had just 1 redirect, so just like page 1 was requested, and I was sent to page 2. And this is the distribution of the status code of all the redirect pages, the ones that were requested, the ones that are intermediate, and the ones that have been actually crawled. So we have stuff that's been redirected to a 404 page, which I think we need to look into these issues. Okay. Next is links. So this is the link summary data frame. It shows 3 samples of each URL and just 3 samples. So the homepage, on this page, we have this link, and this link. There's many more, of course. I'm just showing you here as a sample so you know what's going on. This page links to this page, and this is the text of the link, and this tells me if it's a nofollow or not. Nofollow is false, and here nofollow, this is true. Okay, and this just tells me if it's an internal link or not. If it contains bit.ly.com or not, then it's internal. Otherwise, it's external. Now we start to analyze some of these. This is a network. We create a network with these links from to or source destination, and we have a few metrics to evaluate. So the number of URLs is 898. The actual number of links is 32,233. And the density of this graph is 4%. Now, when you have this kind of website with 898, so potentially if every page linked to every other page on the website, we would have 898 times 898 links. Okay, so if every page linked to every other page, you would have 806,000 pages on the website. Okay, but that's obviously ridiculous. No website does this, but in this case, the density would be 100%. Okay, if no page linked to no page, then the density would be 0. So actually, if we don't count links to from the page to itself, this becomes 898 times 897. Okay, so that's the potential number of clicks that we could have if we divide 32,000 233, which is the number of actual links that we have, divided by this, we get 4%. Okay, so this is the density of, and you can compare various websites and see how linked they are to one another. Okay, next is a table that summarizes all the links and the metrics that they have. So, okay, let me show you 1 second. Okay, so this is the URL itself. This is how many links it has, and the links is the in links plus the outlinks. So 612 plus 107 is 719. Okay, and the degree centrality is the number of links divided by all the URLs that we have. So this is a very central page. These are, and you can see as a percentage how they're distributed. So you can see there's a bunch of pages that are linked to pretty much everything, 60, 50, and then there's a drop off to 14% pretty much immediately here. Okay. PageRank is the classic, Google's PageRank algorithm. You can sort and see which ones are the top, and so on. Okay, and you can filter. So you can say, give me the pages that have in links greater than or equal to 75. Okay, and you get this small table, and you can obviously analyze and go further in your analysis, and you can select also here. You can make another filter. Okay, so I just want the dev pages, and we have these and so on. Remove this filter, and you get, it's a normal filter for all kinds of stuff that you can do with this table. So another thing we can do with links is get the shortest path length. Now, if I want to go from page A to page B, let's say I landed on this website and I land on a random page. The question is, how many clicks do I expect to make or to need to make to go to another page? Okay, that's across the whole website. So as you can see here, in 32% of the cases, it's going to take me 3 clicks to go from one page to another. In 22% of the pages, it's going to take me 4 clicks. In 9% of the cases, it's going to take me 5 clicks, and so on. So this shows me the distribution of the shortest path between, and this is done for all these 32,000 links. Okay, it takes a few seconds to do, but if you want to go from page A to page B, how many clicks, from page A to page C, from page A to page D, and so on. All the combinations are taken. The shortest path is computed, and then we have this distribution. So it shows me how this the linking. So how navigable is this website? You can think of it that way. Okay. Another thing you can do is you can say, give me a certain page, okay, and show me the path to all other pages. So bitly.com doesn't link to anything, which is weird, but if you put the slash, okay. So from bitly.com, from the homepage, what is the shortest path to go to the homepage? Obviously, it's 0. What is the shortest path length to go to the pricing page? It's 1, because it's just 1 click from the homepage to all these pages that have 1. Okay, and there are pages that require 2 clicks and pages that require 3, and so on. So you can take any. So the maximum number of clicks that I expect from the homepage to reach to a page is 6, and you can evaluate. These are the ones. So you can filter and say, okay, give me, where did that go? Sorry, I didn't put the filter here. I'll put it later. But you can easily filter and say, give me the pages that require more than 3 or 4 clicks from the homepage. Okay, so you can do the same thing for whatever, pages/pricing. And here we go. You get the shortest path to every single other page on the website. So you can do this for the most important pages that you have, and so on. Okay. So as another thing you can do is the actual path. Get the actual path from this page, the about page, to all the other pages. So this one shows you the length of the path. This one shows you the actual path. So from the about page, this is the path, nothing, just one URL. If you want to go to the pricing, it's just one click from here to here, from here to here. And these are some long paths. So the shortest path from the about page to this page this is the path. You go to the about page, and then you go to blog, and then you go to category customer service, here, 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 and then you end up on the impactful SMS messaging URL. Okay, so this is, this is the notebook that produces that document. And obviously you can, the idea is that you take this and you modify it any way you want, and add to it, remove, edit, delete, and so on. Yeah, that's it. What do you think?
I think it's great. Yeah, I think the idea of basically shipping an audit as an app like this via Dash is super cool.
Great.
We've kind of been chatting about that internally recently. Yeah, I think it's great. I had a couple of questions about Dash, and then also a couple of other related questions, if that's cool.
Sure, go ahead.
So one question I had was going back to this idea of it looks like this was based on crawl data, but I guess you could do it on log data as well, or some combination.
Mm-hmm.
Does Dash have a drillable tree component that you could use to basically say, these are the segments of my site, and then I want to do roll up for that, like number of URLs and so forth, and I could expand that to see what the URLs are below that. Does that make sense at all?
Let me just show you and make sure I understand. So are you talking about something like this? This one?
Yeah, but kind of like a tree, like a trying to think, like almost like a Windows File Explorer view where you've got the tree.
Oh,
and you
okay.
can see. I mean,
I'm thinking if this is available, like, you want a literal tree structure, like a file browser,
yeah,
kind of.
exactly. Yeah.
I have something that's similar to that. It's Dash file browser, or was it Explorer? No, sorry, it's not this one. So I think you could create one. I don't think
Yeah.
I'm not sure there is a component that shows a literal tree where you can, expand, but I think it should be easy to create.
Okay.
But I can't think of something right now to do this immediately
Yeah.
with this.
Okay.
I'll take a look. I'll let you know,
All
but
right.
that's a great question.
And then I guess the other perennial question that we have is on this sort of exploration of internal link analysis and so forth. Would you be able to get pretty good performance, do you think, on this with a million plus URLs, like larger sites?
Some parts of it are gonna be really, really slow.
Okay.
So if you want to calculate the shortest path from every single page to every single page for a million URLs, that might take a lot of time.
Okay.
So one way to do this is either do it as a batch job and say, look, okay, request, come back in 10 minutes or something, or give it an estimate, because this is quadratic, because it depends on the square of the number of URLs. If I have 10 URLs, I can have 10 times 10 paths potentially. Right. But if it's 1,000, it's 1,000 by 1,000. If it's a million, it's like a trillion paths that you need to compute. Right. So you can either do something like this one, which is just query one URL like here and give me all the shortest paths. or give me the paths from one URL to everything else. But it's, I mean, if you have a million URLs, would you really want to go through a million paths one by one? I'm not sure you want to do that, or
Yeah, I guess it's kind of looking for big imbalances in the link graph in large sites. You know, or the
yes, yes. So one summary might be this as a starting point to see the percentage of number of clicks that might take you from one page to another. But yeah, I mean, let's think about this further. So your question is, I have a million URLs on the website, and I want to see how easy it is to move around the website. Is
Yeah.
that correct?
Yeah.
So we start with this kind of thing and see what the percentages are and see if this is acceptable or not. But of course, it depends on the type of website. You know, in some cases, it's okay to have so many links, so many clicks to go from one page to another. In some cases, you want things to be very so what would you change, let's say?
So I
So
think what I would
go
what would
ahead.
be um, is one major segment of the site getting too much attention at the expense of others. So there's the depth question, but then there's also the vertical side of things where maybe you've got a large catalog and certain types of listing pages or category pages are getting a lot more attention than others from a link navigation perspective.
Okay, so maybe we can do a filter like this. For example, I just filtered the docs section, and we can have special metrics for these pages only.
Yeah.
This might be one way to do it, or maybe just compute the links to these sections. That might make things much easier. So don't compute everything for the whole million URLs. Give me just these 20,000 and show me how well connected and linked they are to and from every other link to the website, if that makes sense.
Basically.
I think maybe it would be good to take from Google Analytics path analysis and then cross analysis. So you know how your users are using your website and what is the shortest or longest path, and then you can see how many clicks they're making.
That's a great point. Yeah. So what we're doing here is getting the theoretical path, but in Google Analytics you have the actual path that people are taking, and you might find some issues there, and you can analyze them here and maybe address these issues by saying, look, people want to go from here to there, but they're actually clicking 4 clicks to go there. Let's make it easier for them, and let's put a link from here to the fourth. Let's create a direct link from here to there, so people don't end up having to. Is that what you meant?
Yeah, by statistics, you can see how much you have on this graph, the distributional graph, and then you can see statistics of the actual path.
The actual people. Yeah, that's great.
Yeah.
That's a great idea. I haven't played with that data yet, but we can. That's an interesting point to check, especially with GA4. So what would you add in general to this template? Would you other than private data like Google Analytics and Search Console? This is public stuff. I'm thinking we can include a robots test as well, because there's a bulk tester in advertools where you can say, okay, here's everything in the sitemap. Test every one of these for every single user agent in the robots file and see which ones are blocked. Where am I blocking myself from the sitemap and from the crawled URLs? This is like 3-4 seconds, can be done very quickly, and as an immediate check. What else would you add to these?
Well,
one of the things. Oh, go ahead, Ray.
No, go ahead.
So one of the things that I found that was really cool, it was when you were doing the text analysis, you had identified that there were a series of URLs that had 2 title tags. what I would want to know in that situation, what are those URLs that had the 2 title tags? Because I noticed that the table shows those. Is there a way to get URLs, to segment those out? Because I mean, that's definitely something that would, you'd want to be fixed.
Absolutely.
And knowing exactly which URLs applied to that would be excellent. And I'm sure that that really would apply to almost anything related to the text analysis. Like if you were the believer of a single H1, and which I mean I am, if you wanted to find how many pages had multiple H1s, you'd want to get that list. So I think if there's a way to extract, URL lists associated with the text exploration, that would be a really beneficial add-on.
Okay, I fully agree. What I think how this could turn out to be is, let's say we go here. This is the text analysis, and there we go. Okay. So you can report this over here. Let me just show you quickly. And URL columns. I want the URL and the title. Right. So these are the URLs, and I can say title df. So title df, where title df title dot string dot split by at string length greater than 1. Okay, so these are the URLs that have more than one title tag. Okay, and you can give it a H2 over here, URLs with more than one title tag. And once you save this, this should be published right here. Okay. So
that's great.
It's very cool.
Cool. Thanks. So you would do this, but before presenting this, you would run this analysis interactively on your own. And if you find something like H1s, multiple H1s, multiple URLs, missing canonicals, and so on, you can create a bunch of tables like this, or just a list of URLs. Say, look, these have more than one title tag. Let's look at those and fix them. So does that make sense?
Yeah,
it does. It does.
Because the problem here is that there's a lot of text elements over here, and
Oh yes.
and that's why it's you take this and you put the ones that you think are big issues and report on them over here, like this one.
I think I missed how you're creating this output from the Jupyter. My laptop crashed in the beginning, so you may have covered this already. But
Well, I didn't mention anything about that. Sorry. So this uses a package called Quarto.
okay.
Quarto.org is a software to convert to so many different formats. So the only thing you have to do is just put this bunch of options. So the title of this is SEO audit analysis bitly.com, format HTML, theme is Cosmo. So if you want the theme to be darkly, you just change this and save, and there you go.
Very cool.
Okay. Echo false means don't show the code. So otherwise the readers would see all these. We don't want them to see the code. We just want them to see. If you say echo true, you would see both and you can override this. Okay. So you can come here and put a comment with echo as true, and let's see this saved. Okay. See, you see the status code's code over here. Because I said echo true. It needs to get, I need to rerun the whole thing because sometimes the JavaScript of Plotly doesn't get loaded. But you see the idea. I just put echo equals true. Okay, so there's a bunch of stuff over here. Table of contents true, table of content location in the body, you can put it right or left, expand true, embed resources false, page layout full. There's so many different things you can do with this. You just have to put the format, the options here, and it gets reflected over here in the document. So all of this interactivity is available except for the dash interactivity. So this page can be saved as an HTML file, and you can just email it to someone.
Okay.
And they can read. And ideally, I think we should add text over here that your own ideas. I think the linking structure over here is bad in this way. I think we can improve it this way. H1 tags have this issue. You can put your own text, just mark down comments, so you can explain these things. And this reads like a document. It's a file that people read, and you can share it and so on. I think we need to have a separate discussion on this because I think it's interesting because this is your template. You just plug in a few values. This is the crawl, this is the robots, and this is the sitemap code, and everything else gets generated dynamically. So you run it once, and then you modify it any way you want.
So then you've done something to add in the dash component interactivity on top of this.
This is running interactively because this is running on my computer right now.
Okay.
But if I email you this thing,
Yeah.
there would be no Python server running,
Yep.
and the interactivity wouldn't be there. But some interactivity would be there, like some of the charts. Yes, this chart. Yes, you can look at this like this, and it would you could see the stuff. You can zoom in, double click to zoom out, and so on. But not the interactive parts. So you
Okay.
can present this on your computer, or if you know how to deploy it online. But this would be a website. But otherwise, you can just present it just the way I did over here.
Yeah. Okay.
And the non-dash parts could be shared in an email or something.
Very cool.
Thanks.
Yeah, that's awesome.
For the interactive tables, it looked like, I would assume AG grid is what's used for those.
Yep.
Now is that Corto just automatically saying that, or did you have to specify that within your Python file?
This is a recent addition to Dash.
Mm-hmm.
So there is a Dash AG grid component that just you just AG grid, and you have all these so many options. Like it's a very rich.
AG grid's awesome.
I know it is. Yeah, like this was a great addition to Dash just a few months ago. So yeah, it's just part of Dash now. So you don't need to integrate or put iframes or work with JavaScript. You just write the Dash code in Python, and you get this Dash grid. And there's, I think you can integrate with the enterprise version, which has additional features. But with the free version, you can do all these kinds of things. So any additions that you would like to see here, or is this comprehensive enough? Or
I'll have to give it some thought, but I think this really covers a lot. I think potentially things, if we wanted to get it, this is more of a site kind of architecture audit, but if you wanted to get into more things around performance, on-page performance, and that stuff, I guess you could include Lighthouse runs or something like that too.
Mm-hmm. Yeah, that would be interesting.
Yeah.
So take a sample of pages and run some tests and report on them. Yeah, that's interesting.
And
Definitely.
maybe rendering, if there is, for a JavaScript heavy site like a React based site or something, some sort of rendering analysis, performance, inclusive of that, but also just in general, is it are you running into any issues with crawl? You know, what type of assets are being exposed and that sort of thing.
Interesting. Yeah. Yeah, we can think of a standard way to do that. Cool.
Yeah.
Great.
This is awesome.
Thank you.